In our next section, we're going to learn about taking the derivative of the natural log function, or what you know as ln. We use the natural log function in calculus much more than we use the log, say, base 10 or base 2 function, because the derivative is so much easier to find. So let's get started with this. If y equals the ln of the absolute value of x, then y prime is equal to 1 over x. If you were to put a function in there for x, so you said y equals the ln of the absolute value of u, then your derivative is just using chain rule. Y prime is 1 over u times the derivative of u du dx. One of the things you can do with natural logs quite often is you can simplify them by using our properties. So recall from our review of natural logs a lot earlier this semester, we had a few properties that we could apply with natural logs. So remember that if you had something like the ln of the absolute value of p times q, I could rewrite that as the ln of p plus the ln of q. What will happen is it's oftentimes a lot easier to take the derivatives of each one individually as opposed to applying chain rule and then product rule. If you have the ln of the absolute value of p divided by q, you can rewrite that as the ln of p minus the ln of q. And then remember that if you have the ln of the absolute value of p raised to the r power, we can pull that r out front. So it's r times the ln of the absolute value of p. So let's do a couple of examples here with these derivatives, and you'll see me apply these properties in many of the situations. On our first one, let's say we have something like y equals the ln of the absolute value of the square root of x. The first thing I'm going to write is the ln of x to the 1/2 power. So I'm going to write it as the ln of x to the 1/2. And then based on the properties I just did, I can pull this 1/2 right here out front. So I can rewrite it as 1/2 times the ln of x. And now you're just taking the derivative of ln of x, which you know. It's very easy. So y prime is 1 over 2x. That's it. So by applying the properties, I can simplify it down. I can remove the chain rule. I can make it a lot easier. Sometimes you can remove it, sometimes you can't, but oftentimes you can. So you really want to try to do that in your problems that you're working on. Let's take one that's a little bit more complex. Let's say we have the ln of the absolute value of the cosine squared of 3x. And the first thing I can do is remember that's the cosine of 3x quantity squared, so I can bring that 2 out front. So I can rewrite this as 2 times the ln of the absolute value of the cosine of 3x. Like that. And now I want to take the derivative of that, which is still going to require some chain rule because I've got to take the derivative of this inside piece in just a moment. The 2 stays out front, so this should be equal to y. Sorry, I should have written that. So y prime is going to be the 2 times 1 over the cosine of 3x times the derivative of the cosine of 3x, which is going to be negative 3 sine of 3x. And then, we're going to get, you can multiply the negative 3 and the 2 and you get negative 6, and then we get sine of 3x over cosine of 3x, so I can rewrite it as y prime equals negative 6 sine of 3x over cosine of 3x, which ultimately is going to be tangent, so I can write it as negative 6 tangent of 3x. So you can incorporate all these different rules that we've had throughout the semester, throughout this derivative stuff, and then with the natural log, a lot of times what happens is that you can have a trig function. You have to simplify them down. So that's how I got the tangent. Let's take one involving product rule. Let's say I have y equals x squared times the ln of x. You can't simplify this at all. We just have to go use product rule. That's all we can do with it. So y prime is going to be the derivative of x squared is 2x times the ln of x. And then you're going to add to that the derivative of ln of x is 1 over x times x squared. We'll simplify that second statement, so I get 2x ln of x plus x. And a lot of times you'll see, especially in our book, when you look at the answers, they'll factor out the two terms of the binomial that have that x in common. A lot of times they'll factor it out, so they'll write it as x times 2 ln of the absolute value of x plus 1. You can see an answer either way. If it's multiple choice, you can see an answer either way. I could write it as the top way, or you could write it as the bottom way. All right, so natural log. Hopefully you'll find some success on this assignment. It's not too bad. Good luck.